Okay, so we're moving on to a new subject now. We're talking about properties of parallel lines. A parallel line is basically just two lines that are of equal angle and equal direction. Two lines that basically will never intersect no matter how far out they extend. So an example of a parallel line would be two lines that go like this, but you know that they're never going to cross each other because they're at exactly the same angle. All right, so that's what a parallel line is. And with parallel lines, if we cut those parallel lines with what's called a transversal, it creates certain types of angles, and that's what we're going to talk about. The thing that we're talking about is a transversal, and a transversal is just a line that cuts through two parallel lines. So in this example, we've got, say, these are two parallel lines, even though they may not look it. But for this example, it's just a rough sketch. We have two parallel lines, and this line that's cutting through them, that's the one that's a transversal. So whenever we say the word transversal, that's what we mean. It's a line that's cutting through two parallel lines. All right. So when that happens, and when we have a transversal, there are three types of angles created by a transversal. We have what's called alternate interior angles. All right. So we have this line cutting the parallel line. We have 1, 2, 3, 4. I know it's hard to read, but these interior angles inside. Think of interior as being inside the lines, and they're alternate, so they're on either side of the line. Okay, so 1 and 2 are alternate interior angles. This angle up here, 3 and 4, are also alternate interior angles. All right. The other type of angles that you can have are what's called same side interior angles. And it's the same sort of idea. They're interior, so that means they're inside of these lines. Same side would be like 1 and 4 here. They're on the same side of that transversal. Contrast that with alternate interior. Alternate means they're on opposite sides on a diagonal. Okay? So 1 and 4 are same side interior angles, and 2 and 3 are also same side interior angles. All right? The final type of angle that you can have, there's actually one more, but we're not talking about it. You can have what's called exterior angles, and that's outside. So interior is inside, exterior is outside. And then we have corresponding angles. And corresponding is basically when you have the line cutting these parallel lines or whatever type of lines you're cutting through here. It creates at 4 angles up here, and we create 4 angles up here. And corresponding just means that they correspond to the same position in the same place. So down here I've got them written which ones are corresponding angles. 1 and 7, they're in the same basic place as the angle. 3 and 8 are corresponding. 5 and 4, and 6 and 2. All right, so knowing those few things, then we can use those to come up with some theorems. All right, when we have a transversal intersecting two parallel lines, then we have these three theorems, and that helps us find the measures of certain angles. All right, so the three theorems are all based on this idea. If a transversal intersects two parallel lines, then, and we have our three theorems. So first of all, if a transversal intersects two parallel lines, then the corresponding angles are congruent. So remember back here we said corresponding angles are angles that are in the same sort of position, but just different angles. All right. So when the lines are parallel and you have a transversal, corresponding angles are congruent, alternate interior angles are congruent, and same side interior angles are supplementary. So if you look back at this sheet, we have alternate interior angles. 1 and 2 are going to be equal to each other. 3 and 4 are going to be equal to each other. The same side interior, the corresponding angles, they're also congruent. So this angle 1 and 7 are equal. 3 and 8 are equal. 5 and 4 are equal. 6 and 2 are equal. And then the same side interior angles are supplementary. And that's sort of easy to see. If 1 and 2 are equal, we'll look at what happens with 2 and 4. These two angles come together to form a straight line, so they add up to 180. So so if 2 and 4 add up to be 180, and 1 and 2 are congruent, then 1 and 4 will also add up to be 180 as well. All right, so those are some theorems that you want to put to memory. They're going to really help us find the measures of some angles that we don't know. Notice here in this example down here, we've got two parallel lines, and here is the symbol for parallel. It's these sort of vertical lines beside each other. This reads A is parallel to B, C is parallel to D, and now we want to find the measures of these labeled angles. All right. So we have to use these theorems, and there is one other theorem here that's going to help us that we talked about earlier in the year, and that is vertical angles are congruent. So where we would want to start here is with the angle that we know, all right? And notice that angle that we know is forming a vertical angle here with angle 8. And we remember from before that vertical angles are congruent. So we can say that the measure of angle 8, just by looking at it, and based on that theorem, that the measure of angle 8 is going to be 50 degrees. Okay, so that's the first angle that we'd want to find. We also can go back to our little theorem here that says that corresponding angles are congruent. All right, remember a corresponding angle here, 8 and 5 are corresponding angles. 7 and this angle here is corresponding. 50 and 1 are also corresponding. So we know that since corresponding angles are congruent, we know that angle 1 is equal to 50. We also know that since angle 8 is equal to 50, that angle 5 must also be equal to 50. And you can see that a couple of ways. If angle 1 is equal to 50 and 5 is a vertical angle with angle 1, then angle 5 also has to be equal to 50. So those three angles we can get right off the bat. The next thing we'd probably want to look at is right here. So we want to jump over here maybe and look at these angles. We know that 7 and 6, if you flip it this way, you can kind of look at it that way. They are same side interior angles, all right? And up here they say that same side interior angles are supplementary. But you can also see it another way, that 8 and 7 are supplementary because they form a straight line. So if angle 8 is equal to 50, or if angle 8 is equal to 50, then angle 7 has to be supplementary with 8. So angle 7 is going to be 180 minus 50. So angle 7 is going to be equal to 130 degrees. All right. We can use that then to figure out angle 6. All right. Angle 7 and angle 6 are same side interior angles. So they are also supplementary. You can also see that angle 8 and angle 6 are corresponding angles. All right. So you can see it. So you can see these angles in a couple of different ways. So angle 6 is going to be equal to angle 8, which we said is 50 degrees. So angle 6 is going to be 50 degrees. Now notice 6 and 2 are supplementary. All right. You can see that. So angle 6 plus angle 2 must equal to 180. Or you can see that 50 and angle 2 are same side interior angles, which they're also supplementary. So that means that angle 2 must equal 130 degrees as well. If same side interior angles are supplementary, then angle 2 must be 130 degrees. 180 minus 50. All right. Now, the only other two angles we need to figure out here are angle 3 and 4. We know that when we find one of these angles, we're going to know the other because 3 and 4 are vertical angles. All right. If we said that angle 2 is equal to 130 degrees, notice that angle 2 and angle 3 are also corresponding angles. All right. And that corresponding angles are congruent. So 2 and 3 are equal to each other. So that means that 3 is equal to 130 degrees. And if 3 is 130, then 4 is the vertical angle, so that's also 130 degrees. So what you want to do is really put these theorems to memory, put these few things in your notebook, and look at it. If you have any questions, bring it to class.